A mysterious 5,500-year-old Sumerian star map recorded a massive asteroid impact that hit our Earth. A 5,500-year-old clay tablet discovered in the 19th century in the underground library of King Ashurbanipal in Nineveh is an astronomical treasure. This ancient document on a clay tablet, excavated in present-day Iraq by Sir Henry Layard, offers unprecedented insight into the astronomical observations that took place more than 5,500 years ago. That's about 3,500 BC in ancient Mesopotamia, long believed to be an ancient Syrian tablet. Computer analysts analyzes to compare it to the Mesopotamian sky 3,300 BC has revealed that it actually has much older Sumerian origins. The astrolabe, this clay tablet star map, is the earliest known astronomical instrument. Is depicted on the table, a tablet. It consists of a segmented disc-shaped star chart with rim markings for the many angles that can be measured. And for more than 150 years, experts have been baffled by the ancient clay tablet housed in the British Museum. The cuneiform tablet K8538 in the British Museum collection, known as the Planisphere. Over 5,600 years ago, an amazing event occurred when a kilometer-long asteroid collided with the Alps in Kaufels, Austria, and unfortunately significant portions of the planisphere on this tablet, about 40%, are missing due to damage caused by the sacking of Nineveh. The reverse of the tablet is not inscribed. Archibald Sayce and Robert Bozaneket discovered the tablet's astronomical relation in 1880 and named it Astrolabe. Leonard William King took the first step towards content analysis by creating a picture facsimile of the tablet. In 1912, his work was published. The image facsimile of the cuneiform writing signs is perfectly transliterated, but he did not translate the facsimile signs into modern language. He joined an archaeological expedition at the same site at Nineveh, hoping to find another astronomical tablet with additional information, but nothing useful was ever found. King presumed that K8538 was a planisphere showing the night sky over Nineveh. 3 years later, in 1915, Ernst Widner released his work on K8538. He made an effort to decipher each of the 8 distinct tablet parts in the book's 6 pages, but the text remained a mystery to him. He described it as magic because the star distributions on the tablet do not match those in the Nineveh sky. He rejected King's term planisphere. 2 authors, Alan Bond and Mark Hemsel, ultimately made significant advances 20 years later. They note in the introduction of the book that up until 2008, there has never been a comprehensive and consistent translation of this unique tablet, which might relate to an impact of a near-Earth object onto our Earth. They retranslated the cuneiform inscription and claimed the tablet recorded the Kaufels impact, an ancient asteroid strike that struck Austria somewhere around 3,100 BC. This caused a stir in the archaeological community. Since geologists first examined the massive landslide of the 19th century, it's been a mystery. It's 500 meters deep and has 5-kilometer circle. It's situated near Kaufels in Austria, and due to the evidence of crushing pressure and explosions, researchers in the middle of the 20th century came to the conclusion that it must have been caused by a very huge meteor impact. Since Kaufels lacks a crater, it does not appear as an impact site should to modern eyes. The idea that it is just another landslide, however, does not account for the fact that confounded the prior experts. What ties the complex Sumerian star chart found in the Nineveh Library subterranean to the enigmatic impact that happened in Austria? The clay tablet may be examined to determine that it was an astronomical work because it features drawings of constellations and names of recognized constellations in the text. Although it's never received a lot of attention, no one has offered a credible explanation for what it is after more than a century. The researchers identified what the planisphere tablet alludes to using contemporary computer algorithms that can mimic trajectories and recreate the night sky thousands of years ago. The K8538 observational tablet was created by an unknown, alert Sumerian astronomer who recognized the historic significance of the event on his astronomical lookout tower, and he decided to record it. Bond and Hemschel dubbed him Luganan's Shaggy Bar, the great man who observed the sky. Half of the tablet records planet positions and cloud cover, just like any other night, but the other half records the object large enough to know its shape even though it's still in space. The astronomers accurately recorded its trajectory relative to the stars, which is consistent with an impact at Koffels to within 1 degree of error. Isn't that something? The observation indicates that the asteroid is larger than a kilometer in diameter and that its original orbit around the Sun was an Aten-type asteroid, a class of asteroid that orbits close to the Earth's path and is resonant with the Earth's orbit. This trajectory explains why there's no crater at Koffels. The incoming angle was very low, like 6 degrees, which means that the asteroid clipped the mountain called Gamskogel above the town of Langenfeld, 11 kilometers from Koffels, causing the asteroid to explode before it reached its final impact point. It grew into a 5-kilometer wide fireball as it traveled down the valley, the size of the landslide. When it hit Koffels, it created enormous pressure that pulverized the rock and caused a landslide, but it did not create a classic impact crater because it was no longer a solid object. Mark Hemschel discussed the Koffels event, said, "Another conclusion can be made from the trajectory. The back plume from the explosion, the mushroom cloud, would be bent over the Mediterranean Sea, re-entering the atmosphere over the Levant, Sinai, and northern Egypt. The ground heating, though very short, would be enough to ignite any flammable material, including human hair and clothes. It's probable even more people died under the plume than in the Alps during the impact blast." As a very rare scientific observation tablet, the K8538 provides the comparative facts that aid in realistic forecasting of asteroid devastation and the resulting mega drought on Earth. The British Museum is now in charge of preserving and protecting this valuable document, this clay tablet, which was created by Sumerian astronomer Luganan Shaggypower. Isn't that something? This is on Hows and Whys by Vicky Verma. Please leave your comments and thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.